Hello students, welcome back to Algebra 2. Today we will be learning the properties of logarithms. Now I'm going to go over these three very quickly because these are kind of a novelty. It's good to know these and it's good to be able to manipulate these. These are mostly used for abstract work and coming up with new theorems, so it's good that you should be able to play with them, but they're not as practical as they are just interesting. So we've got the product property, which states that if I have the log of two numbers multiplied together, that would be equivalent of the log of each of them added together. In the same way, the quotient property, if I have the log of two numbers that are divided by each other, that is the log of the difference of the two. The power property, if I have a log of a number raised to an exponent, that's equivalent to the log of that number by itself multiplied by the power. Now each of these three has a really fascinating proof that I would encourage you to read through in the textbook, but for the sake of time right now, I'm not going to go over the proof. So here's how we would use these. Now in this case, it's saying, given the fact that log 3 is 1.585, is approximately 1.585, and log base 7 is approximately 2.807, let's evaluate each of these logarithms. So the first one you can see is the quotient property. So log base 3 divided by 7 would turn into log base 3 minus log base 7. And then we see log base 3 is 1.585, so I'll just substitute that in, minus 2.807, and using my calculator, that is equal to negative 1.222. Now in this case, I see I've got log base 21, which I notice 21 is 3 times 7. So I can rewrite this as log base 3 times 7. And now that I've got it written as a product, I can say this is the same thing as log base 3 plus log base 7. And then again, using substitution, I would just say, 1.585 plus 2.807, and that is equal to 4.392. Just move that over there. Now this one would be log base 2, and I see 49 there, and what I notice is that 49 is 7 squared. So according to the power property, I can change that from log base 7 squared, and I can take that 2 and just move it over here, so I get 2 log base 7, or 2 times 2.807, which is, let's use a calculator here, 2 times 2.807, that answer is 5.614. Now, moving this into a more abstract situation, let's take that natural log and let's expand it. So I've got natural log 5x to the 7th over y. First thing I notice is that's a fraction, that's a quotient, so I can rewrite this as the natural log 5x to the 7th minus the natural log of y using the quotient rule. Now this natural log y right there is as simple as I can make it, but I do have some other stuff going on with this first log, so I can split that up there. First I've got 5 times x to the 7th, that would be the product rule, so I can say natural log 5 plus natural log x to the 7th, and then I still have this minus natural log y over here. Now I also can use the power rule right here with that 7. Power rule lets me move it from the exponent to the coefficient, so that would give me natural log 5 plus 7 natural log x minus natural log y. And at that point, I can't expand it any more than that. Now condensing is the same idea, but doing it in reverse. So what I would do here is I would see that this one right here is 3 log 2 can be changed to log 2 to the third, which could change to log 8. I'm going to bring this one down, log 9. Oops, didn't bring it down far enough. Log 9 plus log 8 minus log 3. Now I see that all three of these are common logs, so that means that all three of them have base 10, so I can use my rules on them. I've got log 9 plus log 8 is the same thing as log 9 times 8, so that would turn into log 72. Minus log 3, that would turn into log 72 over 3, which turns into log 24. And that is my condensed logarithmic expression. Now, the change of base formula is the most useful thing in this lesson. This is the one that you're going to use the most. Now, before I go into it, I just want to remind you that we have the common log, which will look like this. Log 5 is the same thing as log base 10(5). And then the natural log of 5 is the same thing as log base E5. And the most important thing about these two is that these can be done with your calculator. Calculator has common log and natural log built in. So basically what we want to do is my calculator cannot do something like log 5, 3. There's no log 5 button on my calculator, so I need a way of converting it into either common log or natural log. It's actually a very easy formula. So if we have log base A B, that is equivalent to log base C B divided by log base C A, where C is any value that you want it to be. You can change it into anything that you want. We just remember that the base goes in the bottom of the fraction, the big number goes in the top. Now, if I can make C be any number that I want, there are two obvious choices. I want the ones that my calculator can do. So I can say log base AB is common log B divided by common log A, or I can say it's natural log B divided by natural log A. This is a very simple operation to use here. So evaluate log 3, 8 using common logarithms. Okay, so common logarithm would be just log by itself. So I would just say log 3, 8 is the same thing as common log 8 divided by common log 3. So that would be equal to, I would just say, parentheses, log 8 divided by log 3 is equal to 1.892. We'll round that to 1.893. We're done. Okay, evaluate log 624 using natural logarithms. So that means log 624 is equal to natural log 24 divided by natural log 6. And in my calculator, I can just type in ln 24 divided by ln 6. And I get my answer, 1.773. Round that to 1.774. And we're done. Okay, now, solving a real life problem. So, for a sound with intensity I in watts per square meter, the loudness L of I of the sound in decibels is given by the function L of I equals 10 log I over I naught, where I naught is the intensity of a barely audible sound, about 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of a track so the intensity of the sound doubles. By how many decibels does the loudness increase? So, the thing that I want to point out is that we are going to be doubling it. So, when I ask how much does the sound increase, what I'm asking is what is the difference between the original amount and the new amount. So in this case, I would take the new amount and I would subtract the original amount. Well, the original amount was L of I, but the new amount is L of 2I. I have doubled the intensity, so I'm just going to subtract that. So I see right here, this is my equation, 10 log I over I naught. Li is 10 log, common log, I over I naught. And then I'm going to put this one, this is L of 2I, so that would be 10 log 2I over I naught. Then I'm going to subtract those. Now, this is just a matter of simplifying these. So the first thing that I see is that they both have 10s in them. So the first thing I'm going to do is factor out a 10. So now I have 10 log 2I over I naught minus log I over I naught. Okay, so now I have two of these logs and I'm subtracting them. They're both common logs, so that means that I can simplify this using the quotient rule. I'm going to go ahead and push them together. That means that this would be log, and I've got this one first, 2I over I naught divided by I over I naught. Like that, one big fraction. Now, simplifying this, thinking of this as a division sign right here, I remember from elementary school, 2I over I naught divided by I over I naught would be the same thing as 2I over I naught times I naught over I. So these two would cancel each other out, the i's would cancel each other out, and I would just be left with a 2. So that means this would turn into log 2, and then don't forget the 10 here. So the question was, if I double the intensity, how many decibels does it increase by? Well, it increases by 10 log 2. And it's important to realize that 10 log 2 is a specific value. These are not variables here. So I can actually say 10 times log 2 and just calculate that. 6.931 would be my answer here. Hello class, quick correction. Apparently on my program, log typing this in OneNote does log base 2. So I just did some research and this was incorrect and I want to correct that. In order for me to do it on here, I have to type in log 10. So this one would have been log 10 8 divided by log 10 3. So that would have given me, oh look, the same answer. And actually that makes sense because this would do log 2 and this would be log 10. But according to the change of base formula, it doesn't matter what base you use. That's why I get the same answer. However, moving down to this question here, Log 2 doesn't work because this one's specifically talking about log 10. So I just want to fix that real quick. 10 times log 10 gives me 3.01 decibels, not 6.93. Sorry about the confusion.